Okay, perfect. It looks like we just started streaming on LinkedIn. So let's start with further ado. I see people joining on Zoom, probably on LinkedIn as well. So hello and welcome to the Product Science Live demo. Today we will learn together about PS2 and how it is making performance engineering easy and accessible, and ultimately how it helps you make your mobile apps faster. So for this session today, we have 30 minutes booked for the event. Considering kind of aiming for closer to 20 minutes presentation and also some time reserved for Q&A in the end. So in case you have any questions, please feel free to drop them either here in Zoom, or if you're watching a live stream via LinkedIn, also use LinkedIn chat, and I will make sure to respond to all of your questions at the end of this webinar. Let me first introduce myself. My name is Anastasia. I am the lead product scientist working with PS2 for over 2 years now. All this time, I've been solving performance problems alongside with our clients, finding performance optimization opportunities for them and with them. I've been doing it for multiple different apps across all kinds of platforms in all industries. I was able to find dozens of performance optimization opportunities, some of which were able to speed up our clients' code and make their priority user flows faster by up to 40%. My background is rather technical. I did my PhD in mathematics, but I'm not a mobile engineer myself, and I've never worked as such. And the reason I'm sharing this with you now is that even without being a mobile engineer and without having access to our client's code, what I've been able to do is to uncover these optimization opportunities, and those were implemented and gave real boost in the speed of the apps. So the reason for that happening is largely thanks to PS2 and how great visibility it provides into the code that's executed in the app, into the way how it is executed, and how accessible and intuitive it makes understanding what's happening in your app and how it affects performance. So this is what I'd like to share with you today on this demo. I'll show how PS2 provides this ultimate understanding and visibility of the way your code is running. Now, before we start diving into the tool itself, let's just make sure that you came to the right place and that you find solutions to your problems here. So in case you're a mobile engineer, then facing performance issues and resolving them can be a real challenge. Oh, I said question in the chat. Yes, a recording link will be shared later. So if you're a mobile engineer, as I said, facing performance issues and solving them can be challenging. And there are multiple reasons for that. Among which is that performance work tends to often be isolated from the rest of product development. It happens past the moment when features were rolled out. And most of the tools that are available on the market are often designed to notify you about a degradation, but not to pinpoint the root cause of this degradation. So once you have this notification that something in your app became slower, it will require a lot of attention and tedious work to find what actually caused this delay, this slowing down. And it often involves not only debugging your code, but looking into legacy code written by multiple different teams, which can be painful on its own. And then if you decide to look into traces, if you decide to record traces of your app, manually instrumenting the code that you want to see on the traces requires a lot of effort, a lot of time, and has to be something that you need to maintain whenever the code changes. So it is a significant effort, but it also a continuous effort. So all of this often tends to make performance engineering hard and painful work. But it can not only be hard to performance engineers and mobile engineers in general. If you're a non-technical stakeholder, a product manager, UX designer, if you're in operations on your team, or even if you're a founder of startup, maybe not coding yourself, or even coding, but like not holding a hand on everything that's happening in your app, you can recognize performance problems, especially just simply using your app as a user. You can recognize scenarios in which the app works slowly. So as clear as this experience and impression of it can be, as hard it can be to communicate this to the engineers. Part of the problem here is that existing observability tools, yeah, they would notify you about degradation, but you'll need to set up metrics first. And one thing that we see with the largest companies, very sophisticated apps, having extremely experienced teams dedicated specifically to performance, is still that often metrics are not representing exactly the experience that users are having. Most common example is when for priority user flow, kind of beginning and end of it, any kind of UI updates, animations, other changes that happen in the UI can be cut off the metric, and like loading time is considered instead of actual wait time of the user. This is just one example, but it's very common when these metrics are not tied to real life user experience. It can also happen that like the closing of a single page is counted in the metric for the previous page, even though it contributes to the wait time of the user for the next page to open. So if you just experience a delay using your app, and you're trying to communicate it to the engineers, if they don't have this data indicating what went down, what is happening slowly, it's hard to understand where the problem is. And what adds to this issue is also that you never know whether the slow experience that you have is due to your phone. Maybe you just used it for a year and it became slow and glitchy, or maybe you have a bad network connection. If you cannot support it with field data, yeah, it's hard to justify that something is actually working slowly. And this kind of communication bridge is something that PS2 fits perfectly. So if you are on this side of the app development, I encourage you to take a look at PS2 as well. Now, before we dive to the tool, circling back to how performance optimization actually happens with most of the tools right now, is that whenever you have a degradation, whenever you have this notification, you start the whole investigation process. You use multiple tools. You try to combine context from these tools. This ends up with having pretty much a crime board like this, spending hours, sometimes weeks, to uncover the core reason for the issue. And oftentimes, yeah, you're testing hypotheses. If you're bad on a wrong hypothesis, you'll have to start over, redo instrumentation, add more stuff there, complete the whole analysis from the beginning again. And here is actually where PS2 helps a lot. So there are two parts of our product that let me briefly explain you the first one, the instrumentation, and then we will dive into visualization of the data. Instrumentation, as I mentioned, is a particular challenge on its own. It takes weeks, sometimes months, to instrument your app to a significant visibility level. And yet even then, often core causes of the issues would be tiniest functions that you wouldn't think of causing a delay. Now, what PS2 does is we have a plugin that on the stage of building your app instruments all of the code so that you can actually record traces. When running the app, you can record traces of all the functions, all the methods executing in your code, including third-party libraries. So that saves you time on instrumenting the app as well as on maintaining the instrumentation, because whenever you update your code, instrumentation evolves with it. Now, the second key feature of this instrumentation part of the product is that our AI filtering makes sure that when actually recording the traces, you record just enough information to find root cause of the issue. So it finds this sweet spot between not having enough context, which is common for manual instrumentation, but also make sure that you don't have too much noise, that you don't create performance overhead by recording too many functions, and that you can easily understand what's happening in the app and pinpoint those particular methods that caused a delay. And you will understand how those particular methods are identified from the second part of the presentation. So once your code is instrumented with PS plugin, you can record traces together with screen recording of your app. And for each flow, for each page, you can investigate and understand how code was executed and what was not running optimally. So this is the sweet and intuitive part of performance analysis, because as a user, no matter if you're an engineer or a non-technical stakeholder, what you can do is you can record a trace file while using the app together with screen recording. You can open a particular page in your app, see how it's loading, capture all this, and then you would upload a trace file together with screen recording to PS2. And see everything that was happening in the app, and especially like the trace and screen recording would be aligned, would be synchronized, so that for each frame, when you see something on the screen, you can also see what code was executed exactly at the moment when a user saw some particular frame on the screen. That's done up to a single frame. And you can easily, because of that, you can easily backtrack what caused any UI update and why that UI update happened later or earlier. Besides trace video synchronization, another feature that makes PS2 stand out is the execution path. So not only do we record all the methods and functions running in your code, providing this ultimate visibility, we also record relations between those functions. We record connections. Execution path can be referred as critical path. That is basically relations between the functions. So if you click on a particular function, you would see what scheduled it. So in mobile engineering, you have multiple threads. You have, regardless Android or iOS, you would have multiple threads, and you would have several processes executed in parallel, code running in parallel, and it can be very noisy and hard to distinguish the process that you want to optimize from something that is just running in the background. And here, if you just select a UI update on the video, you click on the method that is showing this UI update, you click on the latest frame, causing this update, and what you will see what exactly caused this update, when it was scheduled, what else was it waiting for, and this way you would be able to backtrack the whole story of what led to the UI update. Now, without further ado, let me jump into the tool and show you how it works. So here we are. This is an example of a trace file that you would see in the app once you upload it to the tool. For this demo purposes, I'm using an open source app so that we can easily look into all the details of the code, but also you can find the code online and check it for yourself, how it was executed, and see what's inside. So this app is a podcast streaming app. It's called Antenna Pod. And here the user flow, the action that we've chose for the analysis was just clicking on a podcast and viewing the podcast details page. So once you open a trace file, what you would see is a video, a screen recording, as well as the trace file where you can scroll through all vertically. You see all the different threads and all the methods running in the code. You can zoom into those methods, see, for example, a network request with a particular URL, but there are also like some smaller methods running in the app. And as I mentioned, for network requests that load images, you can preview the image over here. Happy Halloween. This skeleton is representing the podcast that will be opening for this demo. So if you click on any method, you would see the execution path, meaning what exactly call this function. So I clicked on the real call on response. I see where it was called from, source generator, start next, decoding job. That was also called from, decoding job as well. And that from some function in the main thread, online feed view activity on success. So this is how you can backtrack exactly what was happening in the process you're looking for, the execution path that I mentioned. And regardless of whether you're technical or not technical stakeholder, what you can start from is just looking at the video. So here we are, we opened a podcast page and I scrolled for a little bit. Now you can also play it slower and see which particular UI updates happen, or use this time indicator to figure, okay, what happened? We clicked, the loader started, text appeared on the screen, first one image appeared, second image appeared, and nothing was happening until I started scrolling, and we'll also see how the scroll looked on the video. Now to analyze, to make sense of what is happening in the app here, if on the stage of integration you decided to mark some of your key metrics, for example, here image is set to background, is marked as a kind of key metric of your app, then you can just in one click on this automatically generated flag and see the execution path for the whole thing. And you can separate exactly what caused the image to be set on the background to appear here. Now, what you can do is you can follow this execution path from the beginning to the end and see exactly the story of how the code was executed leading to this point, and then question whether it could be running more efficiently. So we see that it all initiated from online feed activity on create just after this method, which was on item click. So right after user clicked on the button. There was a network request loading some podcast details with URL leading to iTunes. And if I follow it further, there are some smaller methods, consumer single observer on success, start feed download, that triggers yet another network request, loading playlist and some further podcast details, probably the text feed over here. Then we send this information to the main thread, and that should be around the time when text appears on the screen, which also from here we do schedule another network request that, as we saw on the preview, loads the image. That will be, eventually we see that it's a part of the execution path, meaning that it will be the same image that is set for the background. Now, once you have this execution path, you can do two things. You can look at the metrics that you've been measuring previously and assess whether they actually cover exactly what you were expecting them to cover. As well as you can assess the execution path and see whether you had any delays caused by unrelated processes. Like here, for example, not really. There are no delays, nothing is staying in the queue. We see events from this execution path executing right after another. That's a good part. But having this sequence of 3 network requests, you can always ask yourself a question whether they are actually dependent or whether it is possible, because you can see and measure. This is, again, the place where we are loading the image. And you can see that it is happening almost a second, close to 900 milliseconds after the click. So that's a huge delay, and we start loading this image only after, well, at the same time as we are preparing the view to update the text. By this, we're causing a visually noticeable delay when we will be waiting for the network request to load the image. So it's always a great question to ask whether there is a way to retrieve URL for this image early on and download it in right size, so that by the time we have the text, maybe you'll also have the image to show as well. Additionally, this dependency of the network request on the main thread is like in this particular app, it's a simple app. There is not much going on, so there is no additional queue. But what we see in larger apps, when more things are happening simultaneously, is that any dependency on the main thread for something, on the UI thread for something that shouldn't actually wait for the UI update, like loading image over here, is common cause for extra delays. But yeah, as simple as that, you can see and tell a story of how your code was executed and assess it without even diving into technical delays, and use this also to communicate between setting up metrics, KPIs, between product team, engineering team, any other stakeholders. Additional feature, last one that I wanted to kind of flag today and tell you about, is not only about some discrete UI updates when, like, oh, something happened, the image appeared on the screen. The other way how you can use PS Tool to uncover performance optimization opportunities is looking into screen freezes, jitter, and main thread hangs. So as you can see here on the top thread over here would correspond to different frames that appear on the screen. So that is a single frame time between the frame was rendered until the moment when it is changed on the screen with the next one. And what we do in PS Tool, we highlight all the frames that take longer to render and update than we would expect from the phone frame rate. So for example, having 60 Hertz frame rate on the phone that I used to record this trace file, I would expect around 16 milliseconds time for each frame to be on the screen. However, anything that's taking longer, like 30 milliseconds over here, would be highlighted red. Why I think this feature is important and super helpful is that what we often see is that, like, developers know about the issue with main thread hangs, especially when it gets to animations, scrolling, something that should be updating smoothly and seamlessly. It is very important that frames update steadily and you don't have screen freezes. However, the standard tools that would notify you, for example, like on Android, you will get notifications that you are dropping frames only when dropping about 30 frames. While if you're showing the animation or if the user is scrolling, the jitter will be experienced even if 1 or 2 frames are dropping out. That's already would be seen as a jump. So we know that a lot of effort, a lot of attention of developers is directed towards capturing the UI thread load and main thread hangs. However, it is hard to understand what exactly is causing that, especially if, like, the issue is local and tied to a particular UI update. And what you can see with PS Tool, again, this is a simple example of a simple app that's working rather fast. The UI here is not complex, but even here you can zoom into a frame and you would see what was happening here. You will see that layout was inflated, that several cells were created, and then this on its own caused about 1 frame to drop out. And what we see with more complex UIs is that there are layout is more complex. Too many cells are rendered at the same time. Different data is being updated at the same time, as well as in this gap, there is other code that's, like, trying to squeeze into this main thread queue. And what you can do, you can critically assess what is happening there and understand, sometimes to bring those other methods to execute on parallel threads whenever possible, sometimes simplify the way the layout is rendered, but it uncovers a lot of super actionable opportunities to speed this up. I think I will stop here and use this time to switch to the questions. So let's continue our chat. Please join us on LinkedIn or drop an email to myself or our team. Always happy to connect and always happy to dive deep into our tool with your particular project. And yeah, we do have time for questions now. Let me check. I see a question in Zoom. Let me see. Okay. So first question that I have here is how can we leverage PS tool to create and set up metric? Okay, so how can we leverage PS tool to set up new metrics? And if we're using different product analytics tools, how can we utilize it when using PS tool? That's actually a great question. Let me maybe answer it in a few steps. So what I showed here was the automatically generated flag for the metrics that were previously set up that you can use to evaluate metrics that already exist. And if you zoom in, you would see that those flags, the image set to here, image set for cover, there is like an actual method that it is tied to, online feed activity, on resource ready, and this is how you reveal the execution path. Now, if you're setting up a new metric, if you don't have metrics at all, depending on whether you are an engineer or not, what you can just do in PS tool, and let's take this text appearance as an example. What you can do this in PS tool, and you can annotate your trace and add some candidates for those metrics already just based on the video. So I'll put text appears as a reaction over here and place it on timeline. I would also add users tab action from where I see it on the trace. So if I save this and I just put it on timeline based on video, I can also attach it to particular methods. Let's start with the tab. I will be searching for something that says on item click or system call that corresponds to the touch event of the user. So on item click, yeah, this is close enough to what I marked on the video. I actually see animation of user touch starting earlier. So I'll just connect these two. And as for the reaction that I put here from the video, I can find that single frame on which text appears. So I put it a bit later, based just from the video, but here I can zoom in and find the single frame in which text appears. So this is the way to annotate it simply from the video without even looking in the code, but then zooming in later, you can find particular methods that you can attach your metric to. We have online feed activity on success and then layout update later. So this is a way how you can set up metrics from just looking in the UI. Additional way how you can do this, this is the way how you can set up with just from looking at the UI and collaborating with engineers. Additional way how you can test the metrics that you're already using for your product analytics and observability tool would be just create these auto-generated flags that I showed here. The image set to background could be generated from a particular method, but also if you're using any tool that you are using, you can transform those logs that this tool is sending into flags like this and automatically see what caused what this log was triggered by and what was happening previously. I hope that I answered your question. Thanks, Jess. And yeah, let me know if you have additional questions. And in the meanwhile, I think if there are no more questions, we can wrap it up here. And yeah, let's connect, stay updated, join our future webinars and events, subscribe to our page on LinkedIn, and well, see you around.